and welcome to the video on speed and velocity problem solving. The steps that we go over in this video must be followed for every problem that you do for the remainder of the school year. Our problem solving steps include making a table or a list of known and unknown values, drawing a picture, labeling the picture specifically with the symbols from your knowns and unknowns, starting with a standard equation and then doing all of the algebra to solve for the unknown, plugging your values into a working equation, checking to see if your answer makes sense, and finally to box or circle your answer. Today, we will walk through the problem-solving steps for speed and velocity problems. A horse gallops 80 meters with a speed of 12.6 meters per second. How long did the horse gallop? The first step of the process is to list my knowns and unknowns. So from this problem, I know that the horse travels a distance, sigma x, equal to 80 meters. And I know this happens with a speed v of 12.67 meters per second. If you're having trouble picking out your knowns, be sure to look at the units. Meters is a unit of length, while meters per second is a unit of speed or velocity. It's asking how long did the horse gallop? So I'm looking for the time interval, delta t. Next, I draw my picture, and this should be a very simple picture. So here's my horse. He gallops for some distance. He has a speed over a certain period of time. Notice how every single variable from my diagram is listed in my knowns and unknowns. You don't need numbers on your picture. The next step of the problem-solving process is to choose a standard equation. Right now, we only really have two equations, and we are solving for speed. So we will use speed equals distance over time. And we're looking for time. This is a huge step. We must do all of the algebra first to solve for time. So what I mean by that is we don't put our numbers in yet, but we multiply by time. So this gives us the equation times speed is equal to distance. And then to get time by itself, we divide by the speed. So before you put any numbers into your equation must be in terms of what you're looking for. In this case, that is time. The next step is to put in the known values with units. So I look at my knowns and I say, okay, distance is 80 meters. Notice how I'm keeping that m for meters. You must include the units. Divided by speed, 12.67 meters per second. This comes out to be 6.31 seconds. Be sure to include a unit in your answer. And then finally, is that a reasonable answer? I would say yes. And box your answer. We'll do another example to get used to the process. A cow walks with a constant speed of 2 meters per second for 13 minutes. How far did he walk? So we list our knowns and our unknowns. It tells us the speed is 12 meters per second. The time interval, 13 minutes. And we don't know how far. That's what we're looking for. Next, we draw our picture. Again, this is just a cow walking. I'm going to draw my cow as a circle. He's walking with some speed over a time period, and he'll cover a certain amount of distance. We begin with our standard equation. Speed is equal to distance over elapsed time. And we're looking for how far. So again, we do the algebra first. And we're left with the equation. Change in time times the speed is equal to the distance, how far. Before we can put our known values in, let's look here at our knowns. Speed is measured in meters per second, but that time is measured in minutes. So in order to put those numbers into our equation, the units need to match. So we need to convert 13 minutes to seconds. Please note that I'm doing this conversion before I'm entering the time into the equation. It will make your life a lot easier if you convert before you make that substitution. So 13 minutes, there are 60 seconds per 1 minute using the factor label method. Minutes cross out, and 13 times 60 gives you 780 seconds. So now we're ready to use our rearranged equation. So for time, we'll put in that 780 seconds. For speed, 12 meters per second. And that brings us to 9,360 meters. Seems like a reasonable amount of meters for that amount of time. So we can box our answer. So a race car drives 8 kilometers in 812 seconds. What is the race car's speed in kilometers per hour? So we list our knowns and our unknowns. Notice how each of the problems we have a different unknown. So when you're doing your own work, you can refer to this video if you need help with the algebra. Okay, a race car drives 8 kilometers. So this 8, right, is the distance traveled. And 812 seconds, that's the time interval. And our unknown is the car's speed. Notice how the question asks for kilometers per hour, and our time is given in seconds. So eventually we are going to have to make that conversion. Okay, so race cars usually drive in a circle, right? So let's say our car starts here and ends here. So in that time, right, he covered some distance, 8 kilometers. It took him 812 seconds, and again, we're looking for the speed. So as long as your 3 variables are on a picture that makes sense, you're good. So we say speed is equal to displacement, or excuse me, speed is equal to distance over time. So in this case, we don't need to rearrange, right? Because our equation already looks like speed, but we do need to convert that 812 seconds to hours. So we'll say 812 seconds times 1 minute per 60 seconds times 60 minutes, times 1 hour per 60 minutes. And those minutes will cancel. That leaves us with 0.23 hours. So in our problems, we're not too worried about sig figs, but use an appropriate amount of decimal points, which will usually be 2. Now we're ready to put our knowns into our equation. So we'll say speed is equal to the distance, 8 kilometers, keeping your units, divided by 0.23 hours, H for hours, and we're left with 4.35 kilometers per hour. This is a reasonable speed, and we can box our answer.